Next up, we have Mike Allen, who is our lead security architect at Squirrel. Mike, interesting fact about Michael is that he's actually an improv actor also. So maybe we'll get a little bit of taste of that next. Thanks.
Thanks, Eli. Hi, everybody. How's everybody? Yay, we're all here. Quick show of hands. How many people are here because they want to be here? Yes. Whoever put their hand up, why are you here? Is your company making you come here? Boy, I know how that feels. Okay, so I'm going to talk about encryption and security in Accumulo. I am the security architect at Squirrel. They hired me a year and a half ago, January of 2013. Before that, I was working at PGP, which is a company that made encryption and security, email, and disk products. And so, you know, when they hired me and when I learned about Accumulo, which I had not had really any exposure to before, I mean, you know, one of the things I looked at, one of the things a couple people asked me was like, isn't Accumulo already secure? And if it is, why do they need a security architect? I mean, isn't it? It's already secure. It's done. No more work. I can just kind of go home. Do we really need him? You know, the answer is that it is. These guys who made it, these smart gals and guys, they made this really cool system that that does a lot of interesting stuff, and it works really well, and it has a lot of good security semantics. But you know, what else does it need? Like, why isn't it just done? Accumulo has awesome cell-level security capabilities, and you guys are here in large part, or at least in part, because of these capabilities. And you know, if you don't know this already, everything inside of Accumulo is divided into these nifty little key-value pairs. And when I hear a key-value pair, I think of a key and a value, and it's just really straightforward, right? It's a key and it has a value. It's just like a hash table. What could possibly go wrong, right? What could possibly be easier than that? Nothing. Except that it's not that easy. Because these keys are divided into these really complicated parts. And I'm sure as everyone who has ever touched Accumulo has been like, what the heck is this? Like, I thought it was just a key. It's not just a key. And the key has these very interesting parts: row ID, column element, column qualifier, visibilities, timestamp. And among the interesting parts of that is this visibilities thing, which is the heart of the cell-level security. And if you attended John's talk earlier today, you know all about how to do this well now. And if you didn't, why didn't you? Because his talk was really good. God. So in visibilities, you can have these basically define who can see the key, and you're laying out just arbitrary strings as, you know, attributes that a user can be given as they're coming in and talking to Accumulo. And these can be anything you like. I've put a few examples up here. You can AND them and OR them together. You can make all sorts of complicated fun for yourself. It's really cool. But these keys, this system was built because when the people, the smart gals and guys at that undisclosed location were building it, they had in mind a particular threat model. They were thinking about, how do I build a system that's going to help me protect against a particular threat? And the threat for them was the people using Accumulo, Joe and Sven here. They're going to be using Accumulo, the same Accumulo instance at the same time. We're going to have all kinds of data inside of that Accumulo that's really sensitive. And we don't want Sven to be able to see data that only Joe should be able to see. And likewise, we only want Joe to be able to see the data that only she can see and not Sven's data. And we also want to be able to arbitrarily sort of mix this up and combine it and divide it and really get complicated and messy with it, which is great. And it works really well for that particular threat. And that's great. And as we all know, an Accumulo cluster is just as simple as this green box, right? It's one thing that you set up and you never really have to worry about it anymore. It's all just one box. It's just the cluster. Is that? No, that's not right. No, it's really complicated. It's actually a bunch of different machines, and they're all sort of serving the same different different parts of them are serving different functionalities, whether you're talking about an HDFS cluster that has data nodes that's serving up data, whether you're talking about the actual Accumulo nodes themselves. And by the way, if you look across this table horizontally, this is usually the physical piece of hardware, right? Like physically, the data node and the tablet server are typically on the same physical machine, even though they're sort of partitioned in terms of the logical kind of work that they do. And then you've got, of course, this other thing over here, Zookeeper, which is keeping up all this interesting metadata about how your system is configured and what's where and who's talking to whom. And you have your client machines out there, your servers, people on their laptops, et cetera. And in this world, there's not just Sven and Joe, right? You've got all these other players who all have different responsibilities and different levels of access. You've got Molly, who's taking care of the network and all of the glue that holds that network together. You've got William, who's your actual Accumulo administrator, who's tweaking all those knobs that Mike just told us about in terms of how big are things and what are things that people can see and not see. You've got Halim over here, who's probably taking care of all of the HDFS stuff, because you're probably sharing that nice HDFS cluster with not just Accumulo, but all sorts of other different Hadoop-related activities, because your organization or company only wants to buy one Accumulo, one HDFS cluster, and share it across a bunch of different folks. They don't want to buy 4 or 5 per system. So all these people have all different kinds of ways of looking at stuff, and you know, everybody in that boundary is inside of a zone of trust, right? So Sven and Joe, when they access Accumulo, access it through the API, and they're given visibility labels, and the cell level security keeps them on the straight and narrow path. They can see what they can see, and they can't see what they can't see. But Molly can basically see everything passing over the network, and William can see everything because he's lord of the Accumulo cluster. He loves to talk about that at lunch. And Halim can see everything because, hell, he's got physical access to the disks. He could take one home and dump it, which he likes to do because he's weird that way. But we don't judge him. He's a nice guy. So, like, should all of these people be within the boundary of trust that we want around Accumulo, right? Probably not, right? We would like to be able to say, well, we like Molly and we like Halim, but we don't want to have to trust them. We would like to be able to exclude them from our boundary of trust. Not that we're exclusionary that way, we're nice people, but hey, you know, we don't want to train up a bunch of people about what they can and can't see and then trust them, if we can avoid it. So how do we do this? How? I don't know. We do it with encryption. So that's why Squirrel hired me to come in and help Accumulo really develop a stronger story around encryption. So encryption applies in 2 different places typically. You have encryption in motion and you'll have encryption at rest. So we've got 2 different sort of big features inside of Accumulo to deploy encryption at this spot and at this spot. Boy, that red dot really does not show up. I need one of those fancy green laser pointers that blinds everybody in the room. Okay, but encryption's not magic. It's not just like, poof, we have encryption. And it's all turned on and everything is solved. That's not how encryption works. Encryption, when you decide to use it, comes with its own set of questions and with its own set of characteristics that need to be answered if you're going to use it in a well thought out way. It brings with it this fundamental set of questions like, what are you encrypting? Are you encrypting all of the data? Are you encrypting some of it? Are you encrypting the important things? How are you encrypting it? Like physically, what algorithms are you deciding to use? And what are you, how are you deploying it? And all that kind of business, which is all important. And then once you've encrypted something, you've created this secret, be it a password or a key or whatever, that unlocks that data, because just locking it up, I can write you a very fast encryption algorithm that can write it all away, and then you could never read it again. It would be Save a lot of space too, but that's not as interesting as actually developing an algorithm that lets you read the data again. So you created this special key, this sensitive piece of information. How are you protecting that key, right? These are the questions that come up when you start encrypting stuff. So in Accumulo 1.6, which we just released, hooray! There are two big features that have to do with deploying encryption. There's the SSL enablement for Accumulo clients and servers. And there's encrypting data within HDFS. We'll talk about both of these in the next 25 minutes. What's that? Okay. So we'll talk about SSL first. So to do SSL, you need certificates. Who here knows what I mean when I say the word SSL certificate? Raise your hand. Raise it high, raise it proud. Hooray. Okay, so you guys all kind of know what this piece of business is, right? You need to generate these certificates. You'll use one of these tools to generate them. Accumulo does not come pre-built with a tool that's going to let you just like magically generate certificates. You've got to do it yourself. So the first step in deploying SSL is creating your certificates. And you basically, if you're going to follow a typical sort of practice, you're either going to buy your certificates from a place like VeriSign or any of the other certificate authorities out there, or if you're cheap like me, you're going to make your own, because essentially you're not giving the world access to your Accumulo system, and you don't need to like have the world coming into your Accumulo system and say, oh, I know I'm talking to that Accumulo system because I have a trusted cert from VeriSign telling me that this cert's okay. You can deploy your own private certificate authority because you're going to know all of the client machines that are going to be talking to your Accumulo server. So you want to create a trusted cert, a root cert, and then you're going to want to create certificates for each of your individual servers. And the reason you want to do that is just for sort of security cleanliness purposes. If any one of those servers ever was compromised, you only have to replace that server's certificate and revoke it. If you just give one certificate, then you've got to replace them all, and it's a big headache. So you'll want to recreate all those certificates, and then you need to deploy them correctly. In Accumulo terms, what that means is you need to create two different JKS stores, that's Java key stores, and put your certificates inside of those, and there are instructions for doing that on the web, and you can go look up all those details because nobody wants me to read a bunch of bullets off of a screen about how to do that. Does anybody want me to read a bunch of bullets off the screen? Talk about how to do it? Okay, good, because I didn't prepare those slides, so I was really worried for a minute. So you'll create one that contains the trusted certificate part of the trusted cert, not the private key, but the public part. And you'll create one that has the individual server certificate for that individual server, and you'll place them in these two files in your Accumulo Homes configuration directory, and Accumulo will magically know where they are because that's the default. And you need to do one other thing, which is you need to configure one little property inside of your Accumulo site.xml. That's the property there, instance RPC SSL enabled. And you set that to true. Once you've deployed your certificates, you reboot your Accumulo cluster, and ta-da! You have an SSL-enabled Accumulo cluster. You probably also want to distribute, so that would do that across all your servers, not just one. You would need to also distribute to your clients that trusted public certificate so that your clients know, oh, if I see a certificate signed by this trusted public certificate, I know it's okay, and I can go and talk to that machine, and I know that I haven't been intercepted or man-in-the-middled or anything like that. And then you enjoy your SSL. So now we have this connection protected. Accumulo clients to the Accumulo servers. This also has the behavior that when Accumulo servers talk to each other, which they do on occasion, that communication is also encrypted, which is nice. Nice benefit there. Yeah. The question was, does this do anything with the communication for the Zookeeper cluster? And the answer is no, unfortunately, because Zookeeper does not have built into itself any notion of how to turn SSL on, which is deeply, deeply unfortunate. And you guys are all smart people, so someone contribute that back to the Zookeeper community, would you? That'd be really nice. So that settles this part of our encryption security equation. What about this part when we're talking to HDFS? And notice that this arrow here, the network arrow going over to HDFS, is not similarly roped in with this sort of security pipe. And that's because we are going to be doing the encryption of the data going into HDFS inside of our tablet servers, our Accumulo cluster itself, so that when it goes out over that network connection, it's already going to be encrypted. So we don't mind if that goes out over in the clear because it's already been encrypted. So encryption at rest. We use the Accumulo implementation of this uses the Java cryptography extensions. They're built into every JDK that ever comes out of Sun or whoever else builds JDKs these days. And then one of the really nice things about the Java cryptography extensions and the way that they've been implemented is that they are eminently pluggable. So if you don't like the one that comes out of the box with your Java runtime environment, you can pick another one and plug it in. Some of you might be interested in that if you have requirements around how your what kind of certification your encryption library has. Some of you might be interested in libraries that are FIPS certified. The one that comes out of the JDK is not, which is sort of unfortunate, but that's the way it is. But there are lots of them that can plug straight into the JDK that are. That's a bunch of fancy detail that we're not going to talk about right now. Because it's more interesting to talk about what does this encryption at rest stuff actually do with my data that's in Accumulo. So, as everybody knows, Accumulo stores its data in these things called R files. Okay, quick raise of hands, how many people actually know that? That's more than I expected, to be quite honest. R files are just, they're files on the HDFS file system. You could go and look at one with a hex editor and you'd be like, oh, I'm blind, because there's just a bunch of bytes. They're formatted in a very particular way, and this is a gross oversimplification of how they are actually structured. It's just to say they're just a big blob of data. But for our purposes, it works because when you turn on encryption inside of Accumulo for encryption at rest, what happens is each of these individual R files gets its own encryption key. That key encrypts all of the data within that R file to itself. This key is just randomly generated with using a secure source of randomness and is placed directly into, you see it's inside the boundary of this file, so it rides around with this file wherever it happens to end up. And so when you turn this on, you basically get a bunch of files in HDFS, and they're each bearing a key, and that key has encrypted your data. Hooray! We're done, right? We checked the box. Encryption on. All is well. Right? I see some wry smiles. I see some teeth bared at me. This is good. No, you're spotting the problem, right? What you've got in this kind of situation here is a situation where you have bought an incredibly expensive, bulletproof, hack-proof safe. It's a big safe. It's very secure. It's very heavy. It cannot go anywhere. No one can get into it unless you have that combination, right? And that combination could be, thousands of things long. And just to be sure that you don't forget it, you have written that combination down on a very secure sticky note, and you have pasted that sticky note right to the side of the safe just to be sure you don't forget where it is, right? Does this seem awesome and secure and everything's cool? You can shout out, no, that's fine. No, you can talk to me. I'm cool. Thank you. All right, thank you for the person who said no. You're great, you're awesome. Okay, so this isn't good enough, right? So if we're in this situation we've encrypted things, but we haven't really taken care of that pesky key management problem that plagues every crypto system ever developed. When you're encrypting things on your own little laptop, you can solve this problem by simply creating a password in your head and then encrypting these individual keys to that password, which you never write down and is only ever in your head. And the computer, when you need to open that file, can prompt you for that password, right? But that doesn't really work for Accumulo, because Accumulo is a database. It's a service that needs to be always on, always active, and if the server goes down, which they do on occasion, I'm told, it needs to be able to come back up, and without any human interaction, come back up into a state where it can read its encrypted data again, right? So, what do we do, right? Well, the answer is we make another key. We make another key that encrypts all of the keys, or some of them, that we have included into all of our files. And in sort of crypto parlance, that thing is called a key encryption key. And it's now protecting all of the keys that ride along with all of the files. So we're safe, right? Now these keys here can't be opened without you having this key. So if I come along and I try and read these files out, I'm not going to find the safe with the post-it note on the side with the combination bear right there. It's going to be a post-it note, but it's going to be in code. And I don't know what that code is. Great, so what now? Where does this key go? Right? Okay, we've solved one problem. Now we've got another problem. And that problem is, okay, what do I do with this key encryption key? Well, can I create another key? Sure I could. Well, of course I could. I could create a master encryption key encryption key, an MCAC. And I could create a master encryption key. And I could keep going and going until I find the turtles, and then it's just turtles all the way down. No, so you don't need to do that, although some places do that. They don't find the turtles, unless it's strange. So where does this key go? Like, what's the answer? What is the answer about where that key encryption key goes? Does anybody know the answer? Because it could go any number of places, right? It could go into another SQL database. It could go on the file server, along with all the R files. It could go into a key management server. That seems pretty good if you have a key management server lying around. It could go onto the local file system of every box. It could go into memcached. It could go into, I don't know, the Tor onion router and be swirling around the internet forever and ever. It could go anywhere. What's the right answer? Key management? Yes, absolutely. Key management server would be a great answer if you have one, and if you're willing to manage that key management server. And if your organization does that, that's fantastic. Good for you. Awesome. Not every organization does. But not every organization is willing to just say, well, stick it on a file server. That's not my answer either, right? And so if someone can answer this question about what the right answer for this is, congratulations, you've won the Turing Award or whatever, right? Like, this is an unanswerable question, which I think every presentation should have at least one unanswerable question in it. Because this is not a one-size-fits-all answer, right? Every organization is going to have different requirements and different feelings about how I want to handle where ultimately the ultimate secret for my encrypted stuff lands. And since every organization has a different set of requirements, a different set of answers, there's no way that the Accumulo out-of-the-box piece of software can have like the answer for how your key management should happen. So instead, we have a strategy. So there's a pluggable place in the code where you can define how you want your key management to happen. So this pluggable strategy goes by this Java interface name called the secret key encryption strategy. This is a Java class that obeys an interface, and it basically mediates access to the key encryption key that's used to encrypt the file encryption keys that write along with the R files. And the way this works is the Accumulo code basically, it gets configured with one of these classes, which you may write or which may come with Accumulo or may come from another vendor or whatever. And basically the Accumulo code will call to it and say, hey, I just created a new file encryption key. Here it is. Please encrypt it for me so that I can store it along with the R file. And this thing's responsibility is to do that and to hand that back, plus some way, some opaque string that is also expected to be stored along with the R file that tells it, that could tell this strategy again, how did I do that encryption again? What key did I use to encrypt that file encryption key to? So that later, much later, when Accumulo opens that R file back up, grabs that encrypted file encryption key back out, passes it back to this guy can use that opaque thing, and the rest of the Accumulo code doesn't care about what that thing is, to identify, oh yeah, how did I do that again? Oh, right, okay. I know how I did it. I can decrypt it and hand it back. So your key encryption strategy might well make use of a key management server, and if that's great. Your key encryption strategy could just as well put things onto the local file system. It could put things into a SQL database of its own design, right? That's how this part of it works. And this is sort of what that would look like in sort of picture form. It's the thing that sort of allows the Accumulo node to find the key encryption key it needs. These are the options that you would use to turn on encryption at rest inside of Accumulo. You can see they're very straightforward, and there are no questions about them. Come on, guys. No, this is, it's really not that bad. And most of these, the defaults that you would use, which are listed here, are perfectly fine. Except in as much as the default, you know, I've given this presentation at least twice, and no one has noticed that this is actually wrong. This is not the name of this property, but you'll find it online in the docs. The default key encryption strategy that comes out of the box with Accumulo basically puts the key back into HDFS, and that's not very secure. It's secured as much as HDFS and its ACLs are enforceable. But you probably want something that's more interesting, more better, and you can write that yourself, or you can get it from other vendors. So we've done all this work. We've turned encryption on at rest and in motion. What have we accomplished? Well, there was a box that was given to us that said, hey, turn encryption on, and we've checked that box. Oh boy, did we check it. Check the box. But what did we really do? What we really did is we reduced that trusted zone boundary. That's really what we did. We kicked Molly and Halim out of the trusted club. So now, the person that's in the trusted club is probably the person that should be in the trusted club, which is our Accumulo administrator, who probably always will have more or less unfettered access to all of the data, subject to auditing and all that good stuff that one puts around highly sensitive secure databases. And we could even think about, like, how could we in the future, like, push William out slowly from that trusted boundary. And ideas in here might be things like, well, maybe we could think of ways to have dual control over particular operations inside of Accumulo by default. So like giving somebody increased access rights, you can't just have one person do that, you gotta have two people agree to do that. or 3 or however many. That would be one way that we could definitely reduce the amount of trust that we have to put on poor William. And those are ideas that, this is where the community needs to start jumping in. If you guys have ideas for how we can improve this situation, this is definitely an area where folks can contribute. That's the end of my talk, and I'm happy to take questions. So go for it.
So this is excellent. This is all in Accumulo. The question is this HIPAA compliant now for security of data at rest and in transit?
So the question is what we've got up here HIPAA compliant? I'm not a HIPAA lawyer, so I can't say yes or no about whether or not this is HIPAA compliant, but I believe that this, in combination with other practices about how you do your cell level security and how you manage access to your data, you could achieve HIPAA compliance with this solution. Yeah.
In the default config, though, Halim is still in the trust boundary, right?
Yes, in the default configuration, if you don't change your key management strategy, then Halim is still within the trust boundary. That is correct.
And then for the clients, are you also using the client certificates for authentication, or do you still have to use a password?
You can configure Accumulo to require client certificates, client SSL certificates as well. I believe that the Accumulo authentication mechanism does not take that into account. So basically, what that would do is it would enforce at the SSL level that, hey, I need to have a client certificate that I trust. But then when I actually pipe through to Accumulo is still going to demand that I have a username and password, some kind of accounting mechanism.
There's no matchup between the DN and the username.
There's nothing by default. You could take that. There's a pluggable authentication and authorization mechanism inside of Accumulo that could definitely be enhanced towards that. I saw another question. Go ahead.
There was a compromise for if the key encryption key expires, does that require rewriting of all of our files? So you think a way around that?
The question is, if the key encryption key is compromised or expires, does that require a rewriting of all R files? And that's going to depend on what the strategy is around that secret key encryption stuff. So by default, there's only one. The thing that comes out of the box, there's only one, and it encrypts everything. So if that gets compromised, yep, you got to basically rewrite all your data. There's no way around it. Smarter strategy would be to have a rolling key encryption key that would only encrypt a certain segment of data. And this is where those opaque ID concepts become very important, because you'll want some way for the thing behind the key encryption strategy to decide, oh, okay, it was that key encryption key that's used versus this one. And in that case, if one of them got compromised, then one would have to go and rewrite just the data that key encryption key was used to encrypt it. At the end of the day, if your KEK gets compromised, you got to do something. There's no free lunch there, right? There's no way to then absolutely say, okay, well, my data is secure because of X.
The expiration thing, you want to mitigate against that, otherwise at a certain day and time, you have to rewrite everything.
Sure, and that's another reason why having a rolling system would be a little more beneficial. Other questions? Yeah, go ahead. Sure. So the question was about archiving data and what are the security considerations around that, and does this help? And my sort of answer to that is, yeah, this helps, because, I mean, the data starts encrypted. So the thing about archiving data is, once you've archived it, what's the mechanism by which, when you pull it back out from the archive, you can decrypt it? So that goes further into that question of the key management strategy and making sure that you have an archival backup of the key encryption key as well as the data itself. Above and beyond that, and there's not really a lot more to say there, because, I mean, encryption in an archive is basically the same as encryption on disk It's just you'd probably be dealing with a different system, a tape backup system or something like that, that would be mediating the access to the actual data, and that would need to be aware of how the KEK works and all that kind of stuff.
Is there a different scenario for COOP scenario, or so if you have maybe two different data centers that have the same information, but you would encrypt it with different keys at both, or?
So the question, the follow-on was like, is there some handling of like different data centers that's been encrypted to one key versus another? And that, I think, is, I sort of wave my hands at that and say, well, if your key encryption strategy is smart enough, then it's going to know, okay, well, I can get access to both those key encryption keys and I can share data across the data centers. And if it's not, it's not. So there's some work to do there. Same thing. I answered everyone's questions about security encryption. Okay, one more question, says Eli. The key encryption key is generated just like the file encryption keys. It's no different in terms of structure, unless the strategy demands that, say, one might want to use an asymmetric key versus a symmetric key for the key encryption key, which might be important for other reasons. Yeah, it's generated dynamically. It's generated with a good secure source of random data, just like the file encryption keys are. Okay? I'll be available for any other sort of questions that you're too shy to ask. And I'm always available at these contact points on the worldwide internets. Thanks very much, everybody.